Hello guys, this is the last video of chapter 6 and it deals about the polarity of bonds and polarity of molecules, and the learning objectives of this video is 1. Define electronegativity and identify the polarity of covalent bonds. 2. Explain the concepts of polar covalent bonds and molecular polarity. And what is electronegativity? Electronegativity is simply the ability of an atom to attract the shared electrons towards itself. From the periodic table, nonmetals have higher electronegativity than do metals, because nonmetals have greater attraction of electrons than metals. And if you go to the periodic table, you can see this one, down a group, and you can compare across a period electronegativity. Down a group, electronegativity decreases, and across a period electronegativity increases. For example, if you take the group 1, lithium, sodium, potassium, and the like, the electronegativity of lithium is higher than the electronegativity of cesium. And if you go to the across a period, the electronegativity increases. If you compare the electronegativity of lithium and beryllium, beryllium has higher electronegativity than lithium, and the like. From the periodic table, the more electronegative or the most electronegative one is fluorine. And again, if you compare the group 7, down a group, electronegativity difference increase, or electronegativity decreases. This is a periodic trend. So you can use the electronegativity value for each elements in the periodic table. And another thing is the electronegativity difference in the difference in the electronegativity values of two atoms can be used to predict the type of chemical bonds, whether a given chemical bond is ionic or covalent. We can use this guideline. If the electronegativity difference between two atoms is between 0 and 0.4, then the type of bond is nonpolar covalent bond, and this bond is formed by equal sharing of electron. And if the electronegativity difference between two atoms is between 0.5 and 1.8, then the bond type is polar covalent bond, and this bond is formed by unequal sharing of electron. There is partial positive and partial negative. Here we have no partial positive and partial negative because equal electron is shared. If the electronegativity difference between two atoms is between 1.9 and 3.3, and the bond type is ionic bond, and this bond is formed by electron transferring, there is totally positive charge and negative charge. This is one way. For example, if you consider the hydrogen molecule, the bond between hydrogen and hydrogen is nonpolar bond, and the molecule is nonpolar molecule because its electronegativity difference is 0. If you consider the bromine chloride, and the electronegativity difference is 0.2, which is in this range, and the polarity is, or the bond type is nonpolar covalent bond, and this is formed by equal sharing of electrons. And if you consider the bond between hydrogen bromide, and there is the electronegativity difference is 0.7, which is in this range, and this is also this is polar covalent bond, but the sharing of electron is unequal, so there is partial positive and partial negative. And if you consider the sodium chloride, the bond between sodium chloride is polar bond because the electronegativity difference between two atoms is 2.1, which is in this range, and the type of bond is ionic bond. This bond is formed by transferring of electrons. So in this way you can check whether the given chemical bond is ionic covalent or non-polar covalent or polar covalent and the like. Another thing is a bond becomes more polar as the electronegativity difference increases. If the electronegativity difference increases, then the polarity of the molecule becomes high. This is one concept about the electronegativity. Another thing is covalent bond polarity and covalent molecular polarity. Let me explain first bond polarity. Based on the bond polarity, molecule of covalent bond can be classified into two, that is nonpolar bond and polar covalent bond. What is the difference between these two, the nonpolar covalent bond and the polar covalent bond? The difference is this one. For nonpolar covalent bond, This non-polar covalent bond is formed from atoms having similar electronegativity difference. It may be formed from more electronegative and more electronegative, or less electronegative and less electronegative negative. And the shared electrons are equally. There is even distribution of electrons. You can see, for example, the bond between hydrogen and hydrogen, fluorine and fluorine, there is equal sharing of electron. So there is no partial positive and partial negative. This is non-polar. Another thing is there is no poles, that is partial positive or partial negative developed. And non-polar covalent bonds have zero dipole moment. Dipole moment is a measure of the molecular polarity, that is its unit is dpi. Example, the bond in diatomic molecules like this, the same atoms the same atoms, the bond between the same atoms, that is diatomic molecule. This is non-polar. Another thing is polar covalent bond. This polar covalent bond is a bond formed when two dissimilar atoms combine together. That is, electron shifts towards atoms having the more electronegativity, and this is an symmetrical electron cloud. For example, if you see the bond between carbon and hydrogen, carbon is more electronegative than hydrogen, so it have high electron density. And again, similarly, the bond between boron and fluorine has high electronegativity and have high electron density. This is one. Another thing is the more polar bond is formed from more electronegative atoms. In the polar bond, the more electronegative atoms acquire negative charge, and the less electronegative atoms acquire positive charge, and it forms dipole. For example, if you consider the bond between carbon and oxygen, oxygen is a more electronegative negative atom, so it acquires negative charge, that is partial negative, and the carbon is the less electronegative, and it acquires partial positive, and the like. Another thing is this polar covalent bond is mostly formed from heteronuclear molecules, that is molecules of different atoms. For example, this, if you consider the polar bond in hydrogen chloride, there is an equal sharing of electron. Chlorine is more electronegative, so it has more electron density, and its charge is negative for chlorine and positive for hydrogen, and the like. Similarly, for the bond between hydrogen and fluoride, there is unequal sharing of electron. Fluorine acquires more electron than hydrogen, so fluorine is more electron denser than the hydrogen. This is another example. This is the covalent polarity. Another thing is covalent molecular polarity. This is not bond polarity but molecular polarity. Note that the presence of polar bonds does not always result in polar molecules. If you consider example carbon dioxide, the bond between carbon and oxygen is polar, but the molecule by itself is non-polar because the polarity cancel each other. If you consider this diagram, the bond between oxygen and carbon is polar, and the bond between this carbon and this oxygen is polar, but the molecule as a whole is non-polar because this polarity and this polarity cancel each other, so the overall dipole moment becomes zero. So the molecule by itself is non-polar molecule, but the bond is polar. Similarly, with carbon tetrachloride, the bond between carbon and chlorine is polar, but the carbon tetrachloride by itself is non-polar molecule because the polarity cancel each other. Similarly, third example is boron trifluoride. The bond between carbon and fluorine is polar, but the boron trifluoride molecule is non-polar molecule. So what is the polar molecule and what is the non-polar molecule? The polar molecules are molecules of less geometric symmetry, that is not the same direction. Any diatomic molecules that has a polar bond is polar. Example, carbon monoxide. It is diatomic molecule that has polar bond, so the molecule becomes polar for diatomic molecules. And polar molecules occur when the dipoles from the individual polar bonds do not cancel each other. Consider this example. If here we have the polar bond between hydrogen and the chlorine, but this bond cannot be cancel each other, so chlorine hydrogen chloride molecule is polar. If you again consider the bond between water and the molecule by itself, here there is partial positive and partial negative bond, here also partial positive and partial negative, but the bond the partial positive and partial negative do not, this dipole do not cancel each other, so water by itself is polar bond. Note that if one atom is surrounded by similar atoms and if there is one lone pair as the central atom, that type of bond is considered as the polar bond. If one atom is surrounded by the same molecule and if there is no lone pair as the central atom, this molecule becomes the nonpolar molecule. In this case, there is lone pair in the central atom, so this molecule is considered as polar molecule. Similarly, you can consider these molecules. Nitrogen is surrounded by three similar hydrogen atoms, but there is lone pair as a central atom. In this case, such type of molecule is considered as the polar molecule. If there is no this lone pair, then the molecule becomes non-polar. But here in this case, there is one lone pair, so this ammonia is polar molecule. Similarly, you can consider this. But this is a different case because the atoms that surround this molecule are not the same, because this is fluorine and this is hydrogen. So if the atom is surrounded by different atoms, totally that molecule is considered as the polar molecule. This is about the polar molecule. Non-polar molecule is a molecule in which the molecule as a whole is non-polar if a central atom is surrounded by the same atoms and not contain lone pair as a central atom. For example, if you can take these molecules. Second, a molecule as a whole is considered as non-polar if all bonds are non-polar bonds. Example, these molecules, because they contain only non-polar covalent bonds. Those molecules that contain only non-polar covalent bonds are non-polar molecules. Another thing is a molecule as a whole is considered as non-polar if high symmetry is existed between the molecules. And another thing is the molecule as a whole is considered as non-polar where the polar bonds cancel each other due to symmetrical arrangement around the central atom. Consider this molecule as example. There is a symmetrical arrangement of the bonds. This is partial positive and this is partial negative, partial positive and partial negative. So the two carbon hydrogen dipole cancel each other and then carbon monoxide becomes non-polar molecule. Similarly for carbon tetrachloride, these four carbon hydrogen, carbon chlorine bonds dipoles cancel each other, so the molecule as a whole becomes the non-polar. This is one thing. Another thing is the ionic polarity. Ionic polarity. Note that all ionic compounds are polar, but there are some factors that affect the ionic polarity. One is the ionic size. One cation with smaller size is more polar. That is the case of cation. Example, if you compare these compounds, which one is a more ionic compound? Lithium chloride is a more has a more ionic character because it says that cations with smaller size is more polar. If you compare the size of the lithium ion, sodium ion, and the cesium ion, now lithium ion is has smallest cationic size. So lithium chloride is more polar than the others. And another thing is compounds with large anion. This is in anionic case. Compounds with large anions are more polar. If you consider the the ionic characteristics of lithium fluoride, lithium chloride, lithium bromide, and lithium iodide. Lithium iodide has more ionic character than the other because iodine has large ionic size. Because of this, lithium iodide has high ionic character. Another thing is another factor that affects the ionic polarity is the oxidation state. Compounds with higher oxidation state have high polarity. For example, if you compare the polarity character or the ionic character of iron trichloride and iron dichloride, iron trichloride is more polar than iron dichloride because the charge in this compound is +3 and the charge in this compound is +2. So compounds with higher oxidation state is more polar than compounds with less oxidation state. This is one point, and let me explain more this with simulation. The first one is the atoms with two molecules. Atoms with two molecules. Let me start from the beginning. If you consider these molecules A and B, and if both A and B are less electronegative, and if you see the bond dipole, there is no bond dipole, there is no partial charge, there is no and the character of the bond character is more covalent because more covalent bond is formed from less electronegative and less electronegative, or from more electronegative and more electronegative. So there is more to form more covalent compound. The two atoms should be more electronegative and more electronegative, or less electronegative and less electronegative. In this case, if we apply the electrical field, this atom does not. These atoms are not affected by electrical charge. But if we increase the electronegativity of one of the atom, for example, if I increase the electronegativity of A, what will be the characteristics of bond dipole, partial charge, bond character, and similarly the electrical potential and electrical density? Look that if I increase the electronegativity of A, then look what is happening in the molecule. That is bond dipole, partial charge, bond character, and electron density and the electrical field. Observe the phenomena, and also the bond character shifts from more covalent to more ionic. You can see if I shift these electrons, then the partial negative shifts towards the positive electrical field, and the electron density is more denser. Electron is more denser in the A, that is atoms with more electronegative. Similarly, if I increase the electronegativity of B, what will happen? It shifts the direction towards B, and then the electrical field becomes negative charge. B is attracted by this positive electrical field, and there is more electron density at B. Similarly, for three atomic molecules, if you consider all of these three atoms are less electronegative, no bond dipole formed, no molecular dipole, no partial charge, and does not affected by electrical field. But if I change the electronegativity of for example, one of these three atoms, for example, if I change electronegativity of A, if I increase the electronegativity of A, look what is happening, and A becomes more electronegative, and if I increase the electronegativity of B, and B becomes more electronegative, and the direction shifts to positive electrical field. Similarly, if I increase the electronegativity of C, what will happen? This is the phenomena. Thank you for watching today's video. This is the last video of chapter 6. See you next time. Bye bye.